Okay. Today's lesson is about rationalizing the denominator. And so our learning intention is to learn the skills of rationalizing the denominator of an irrational term. And to be successful, we will need to be able to know the difference between an irrational and a rational term, have the ability to rationalize the denominator of a term correctly as well. So let's start. Okay, so what is an irrational term? What is a rational term? A rational term is a term that can be expressed as A over B. And some examples are like this. So we have the fraction of 2/3. We also have integers such as 4 or 5, because they can be written as 4 over 1 or 5 over 1. An irrational term is when they can't be written as a fraction. So things such as square root 2, pi or e, they're all irrational terms. So if what we're trying to do, if we have a fraction such as 1 over square root 2, we want to rationalize the denominator and make it the denominator a rational term. Okay, so that's what rationalizing the denominator. It is converting a fraction that has an irrational term in the denominator into a rational term, such as an integer. And the reason why we do this is it's easier to add or subtract or to operate with fractions that have a rational denominator. For example, it is easier to add square root 2 over 2, add those together, rather than having an irrational term on the bottom. This is a lot harder to do. Okay, so there we go. Okay, so let's do some examples. So we're going to rationalize this 2 over square root 5, and obviously this is an example where there is a single irrational term on the bottom. And the way we do that is we're actually going to multiply this fraction with square root 5 over square root 5. And the reason why is because of the rule that square root a times square root a leaves us a. Okay, so in this example, 2 times square root 5 is just 2 square root 5, and then square root 5 times square root 5 is just 5, because square root of a number multiplied by itself gives you the number squared. Okay, and that's how we rationalize the denominator. So the solution to 2 square root 5 rationalize, it's 2 square root 5 over 5. So another example where there's the denominator is an irrational term. So square root 7 over square root 3, we're going to times that by square root 3 over square root 3. Okay. 7 times square root 3 is square root 21. Square root 3 times square root 3 leaves us with 3. Okay. So an example, example 3. Okay, here we have the denominator with an irrational term of a square root b. And what we're actually going to do here is we're actually going to square root it. We're going to multiply it by just square root 5. Okay. So if I did that, 2 times square root 6 times square root 5, so that's going to be 2 square root 30. We can simplify that down later on. And then 3 multiplied by square root 5 times square root 5, so 3 times ends up being 5 is 15. And I just want to show you an example where what would happen if I multiply by 3 square root 5. So if I still had 2 square root 6 over 3 square root 5, that's the original question. If I multiply that by 3 square root 5, rather than just square root 5, I would get 2 times 3 is 6, 6 square root 30. 3 times 3 is 9, 9 times 5 is 45. We can simplify that by taking out 6 over 45 is 2 over 15, and that's still square root 30. So you still come down to the same solution, but it's just a lot faster by multiplying it just by the square root part. Okay, so if we wanted to summarize so far, we're going to multiply the top and bottom by the irrational term. Okay, so some more examples. Okay, here we have 1 over square root 3 plus square root 2. And to solve a question like this, what we really want to be doing is reminding ourselves the binomial products of perfect squares, the difference of two squares. Yep. So if you had a plus b multiplied by a minus b, you would get a squared minus b squared. Okay, so to solve something like this, what we're going to do is going to use this ideology, and we're going to multiply it by its conjugate. So square root a minus square root b and square root a plus square root b are called conjugate surds. What does that mean? So a conjugate is formed by changing the sign between two terms in a binomial. So two terms. For example, the conjugate of x plus y is x minus y, and that's from study.com. You can find that on study.com. So other examples such as x plus 3, the conjugate to that is just x minus 3. Yep. For example, the one that we have up here, we've got square root 3 plus square root 2. The conjugate of that is going to be square root 3 minus square root 2. So what does that do? So if we've got if we've got a term and we're going to multiply by its conjugate, we should get to the first term squared minus the second term squared. And when we think about this, so something like that would be x squared minus 9. Well, if we think of it the same thing, so square root 3 times square root 3 is just 3. Square root 2 times square root 2 is 2. So 3 minus 2 gives us 1. Okay, so an example. So if we do this example, we've got the question of 1 over square root 3 plus square root 2. What we're going to do is we're going to multiply the top and the bottom by the conjugate. So that's a subtraction minus sign. Okay. So 1 times square root 3 is just square root 3. 1 times negative square root 2 is negative square root 2. And square root 3 plus square root 2 multiplied square root 3 minus square root 2 is, as shown here, is just 1. So the solution of rationalizing this is simply square root 3 minus square root 2. We'll do one more example. Okay. Here we have we've got some 2 irrationals on the bottom. So we're going to actually multiply by its conjugate. So the conjugate of 3 square root 5 plus 5 square root 7 is 3 square root 5 minus 5 square root 7. 3 square root 5 minus 5 square root 7. Okay, so if I do the tops, this term multiplied by this term, so 2 times 3 is 6. Square root 3 times square root 5 is 15. Square root 15. Okay, now it's this term times the last term. So 2 times negative 5 is negative 10. And square root 3 times square root 7 is square root 21. Okay, now we've got this term multiplied by this term. So 3 times 3 is 9. And square root 2 times square root 5 is square root 10. And now it's this term multiplied by the last term. So 3 times negative 5 is negative 15. And square root 2 times square root 7 is square root 14. Okay, now that's all over this denominator. So 3 times 3 is 9. What I'm going to just do is put it here. And then 5, square root 5 times square root 5 is just 5. Yep. And now 5 times 5 is 25. Square root 7 times square root 7 is just 7. So I can't collect any like terms from the top. So it's just going to stay as 6 square root 15 minus 10 square root 21 plus 9 square root 10 minus 15 square root 14. And that's all over. You've got 9 times 5, which is 45, minus 25 times 7, so which is negative 130. So I can bring out the negative sign to the front, and that's just going to be 6 square root 15 minus 10 square root 21 plus 9 square root 10 minus 15 square root 14, all over 130. Okay. Notice that I put it in brackets. If we wanted to put it out the front, it would be minus 6 square root 15 plus 10 square root 21 minus 9 square root 10 plus 15 square root 14. As you could, if you take out the sign, it's just going to change all the signs at the top, and that should be your final answer. And we can always double check, use our calculators if this was an exam. 2 square root 3 plus 3 square root 2 3 square root 5 plus 5 square root 7. That's the solution numerically, and I'm going to test it using my final solution. So here minus 6 square root 15 minus 10 square root 21 plus 9 square root 10 minus 15 square root 14 all over 130. So there's my solution for what I found, and that's the same as the original, which is exactly what we want. Okay, so to summarize, when rationalizing the denominator, we multiply the numerator and denominator by the irrational term. If you get something like a over square root b, so we can times it by square root b. Or if you get something like a b square root c, we're just going to times it by square root c. Or by the conjugate of the denominator. So if you have a over b square root c plus d square root e, we're going to multiply it by b square root c minus d square root e. And obviously, if this was a negative here, then these will be positive. Okay, and that's it. Thank you very much.